Okay, so this week we did the spiral kinematics, um, 28, page 28, and so we were asked to kind of explain what we did and how we got what we did and kind of what mathematical equations and why. And so for my explanation, at first when I kind of looked at it, I first was kind of confused because it looked like there was 6 unknown variables, and I can kind of show you up top too. But I was just kind of confused because I didn't know how. I've only seen 4 equations, so that kind of freaked me out because I didn't know how to handle finding 6 unknown variables. But since the truck and the car end up colliding at the end, it would mean that the events for T2 and R2 for the truck and the car must be equal. So that I kind of estimated and figured. So then I still only had 4 unknown variables, which would be the time 2, the R2, and the velocity of the car 2, and the velocity of the truck 2. So specifically I had to try and find positions for the equations for the car to be able to equally run into the truck as the truck collides with the car. And so what I did is the first object I used the car, and I said for its event that it was accelerating towards the west because at first, although it was accelerating towards the east, my arrow first is going towards the left, going towards the east, but then it ends up going towards the west. So then it turns around and then it starts accelerating and goes towards the west. So that's why my event starts there. And then the event 2 for the car would then be the collision. The object for the second one is the truck, and the first event for the truck is where it starts to, it accelerates also towards the west. And then for that second event, it's also the collision as well. So in the story given above, it actually gives you the time, which would be 0 for object 1 and event 1. It doesn't give you a rate, so I put 0, and then the velocity it actually already gives to you. It says that it's traveling at 20 meters per second, and it turns around and then it goes back. And it starts accelerating at 2 meters per second squared. So that's how we get our acceleration for our object 1, event 1, is that it gives it to you. And then my velocity obviously is 20 meters per second. And so then for my object 2, the truck, the time is 0. And then the rate it actually gives to you is 60 meters. And then the velocity it gives to you also, which is 16 meters per second, and it also gives you acceleration for that, which is 1 meter per second squared. And so then for my equation, I tried to figure out, obviously, V2 and R2. So I first took that the R2 of the car would equal, let me scroll down, would equal the R2 of the truck. Okay, and so then I just plugged in the mathematical equation with our numbers that we were given, so velocity and rate, and then I was able to find that the rate was 2.32. So then I plugged that into the ratio for the R2 for the car, and I got 51.04, and I was also able to plug that in and get for the velocity 2 of the truck was 39.44 meters per second, and then the velocity 2 for the car, I plugged in that 2.32 also with the 20 meters per second and 2 meters per second, and that was 41.53 meters per second. So these is my mathematical equations and how I did my spiral kinematics 28. And alright, that's it. Thank you.